Hello! This unit focuses on a very important question. What is health informatics? First, we are going to explore some general definitions and then provide descriptions of several fascinating health informatics subdisciplines with examples of important projects. Health informatics is built on several other sciences, and it is sometimes hard to distinguish it from computer science or health sciences. So what is so unique about health informatics? In essence, health informatics is the study of information about human health. This information potentially includes molecules, genes, medications, patients' diseases, living environment, regional pollution levels, and many other data. Imagine a doctor attending to a child suffering from asthma. The doctor knows that the patient's father has also suffered from asthma all of his life. The doctor may start noticing a trend that many of his asthma patients have blood relatives who are also asthma sufferers. However, to determine that asthma runs in the family, in other words, is hereditary, a large amount of data on people with and without asthma needs to be collected, sorted, and analyzed. This data may include a list of patients' complaints, tissue samples, a description of their living environment, and many other factors. Recognizing what makes people sick is the first step that needs to be taken toward finding a cure. A doctor may be good at recognizing and interpreting signs and symptoms, but there are only so many patients a doctor can see. Computers can assist here, since they have been designed to be able to store, sort, and manipulate huge amounts of data. So what is the goal of health informatics? Health informatics studies ways in which health-related data can be presented to the clinician for interpretation, thus building meaningful information critical for improving human health. According to a white paper published by the American Medical Informatics Association, this essence is captured in a more formal definition of health informatics as the interdisciplinary field that studies and pursues the effective uses of biomedical data, information, and knowledge for scientific inquiry, problem-solving, and decision-making, driven by efforts to improve human health. Health informatics is an umbrella term that includes several subdisciplines. Here are a couple of examples of the diverse subdisciplines and concrete projects. A Drop for Research is an initiative by Maccabi, the second largest health insurance in Israel, through which patients' biological samples like blood and urine are collected and stored in a large data bank of biological samples. These samples are connected to patients' electronic medical record to examine linkages between genes, diseases, and other factors, like lifestyle. The goal of this initiative is to discover risk factors and to personalize treatment. This is an example of bioinformatics, where molecular biology is used to understand and explore the influence of the smallest particles making up the human body, like genes or molecules, on medical phenomena like diseases. Structural or imaging informatics occurs on the somewhat larger scale of human anatomy, specifically anatomical features that can be captured with imaging techniques like computer tomography, bone density scans, and others. One example is a study by Brazilian researchers where computed tomography images were used to teach computers to identify subtypes of lung cancer and predict metastases. Medical, nursing, dental, and other clinical informatics often deal with patients and groups of patients within a particular discipline. For example, nursing informatics uses nursing knowledge to promote human health. A recent study in nursing informatics conducted in northeastern USA applied a computerized algorithm to identify high-risk patients and prevent negative outcomes, like rehospitalizations. Public health informatics is on the other end of the spectrum, and it uses information about patient groups or whole populations. It may involve epidemiology, surveillance, data on health and disease, and environmental data. For instance, the distribution and spreading of the H1N1 virus in Mexico, also known as the swine flu, was studied using throat swabs from the repository of the Health Ministry Regional Laboratory that were collected as part of a surveillance system. Then there is translational bioinformatics that encompasses public health informatics, clinical informatics, and sometimes bioinformatics. An interesting example of translational informatics may be the recent development of a web portal called IMPACT for information on gene-specific cancer treatment. Research has connected tumors to variations in genes, and several drugs have recently been designed to target these gene variations. The IMPACT website, developed by a group from Colorado, hosts 1,751 target genes and variations that have been linked to 776 approved drugs to streamline personalized treatments. So you see, health informatics deals with collecting, storing, and analyzing huge amounts of data that are beyond human capacity. These data are then presented to researchers and doctors who make sense of the patterns they see in the data. With increasing volumes of data, the role of health informatics in research and development of new treatments has become critical over the years. To summarize, health informatics encompasses a spectrum of data sources from the tiniest molecules in the human body to data about hundreds of thousands of people spread over different continents. Health informatics may be used in basic science on the one hand, or in the clinical treatment on the other hand. Welcome to this exciting world. I hope you will enjoy it and appreciate it as much as I do.